Hi, welcome to third video in the series where we are explaining SSE transport. SSE suddenly became known when MCP started. MCP made SSE one of their most important mechanism to communicate. So a quick recap. Welcome to Techie Talks AI. I'm Sri from Shogini. On this channel, we bring you hands-on demonstrations and insights into the latest tools and trends to help you get started with ease. Don't forget to subscribe and be a part of our journey into the future of technology. If you haven't watched the previous videos, SSE is a client to server communication. So this is the server, this is the client. SSE is a one-way communication. So one-way means how does it happen? Can the client initiate the request? No. Whenever server wants to send data, it'll just send data like broadcasting. It is up to the client to receive. But this is a streaming channel like WebSockets. This is a streaming channel. So continuously, once the client establishes an SSE connection, it can continuously receive messages from the server. So remember, SSE means one-way communication. And it is useful for real-time updates. It is a one-way communication from server to client, and it is good for streaming data. Okay, and SSE compared to WebSockets or HTTP polling. So here is one way, whereas WebSockets is a two-way communication, and polling-based HTTP request, we will have to continuously request for data. And this is good for live updates, and this is good for chat, gaming, and voice-based AI chatbots, etc. Efficient, both are efficient. And here there is a latency because that depends on the polling frequency. Okay, so that is a quick recap. And SSE compared to REST stands for representational state transfer. And here, when it comes to REST, there is a request from the client to server and then server response. Whereas SSE is one-way streaming from server to client. So SSE is good for real-time updates, especially for dashboards. It is very good. And REST for request-based communication. And I'm repeating this, so please don't mind my repetition because techie community is not very clear about this. This is important. Combined system implementation is our MCP. MCP, server to client communication, is SSE, and client to server request using REST HTTP. Okay, so let's look at the third demo. The code is given in the description. When you git clone, you will get the Techie Talks AI folder, cd into SSE, and v3 MSG. I'm in this folder. So there we have the Docker Compose. Is there any change in the Docker Compose? There is no change. The server is same, client is same, and the Streamlit front end is same. Absolutely no change. And SSE server script is same, SSE client script is same. Only thing that we have changed is in the front end, we are adding a messaging mechanism. So we can send message from the client to the server. That is how MCP communication happens. So here, when we click the send button that we will see now, we will post messages to this messages endpoint. So there is a change in the server. So server is not same. Server has got one messages endpoint, and this is the method that handles it. So receive data is expected to be in JSON format, and if the data is empty, it will say no message provided. then it puts the message into a list called message_queue. Okay, status received and the received message. So it returns status, message received, and the message. Okay, so this /messages does two things. One is it collects and pushes the message into a queue. It also returns the message. So when you post a message, the endpoint also returns the message. And this event stream, how is this event stream getting the message? Is it giving dummy message? No, it is actually reading the queue. See here, message queue.get. So in our previous example, we created dummy message every 2 seconds. In this case, we are not creating the dummy message. Whenever we receive a post request on this messages endpoint, that message gets pushed into a queue, and that will trigger a response from the SSE endpoint. So let's see it's working. I'm in the v3-msg folder, Docker compose up, building of Docker images be completed. Okay, so that container name is present. Okay, SSE client. Okay, all the containers have been cleared. Okay, front end is running. Okay, so it's waiting, and it is actually receiving messages. Even when we are not posting, it is receiving messages. Let's see why. This is the SSE server. So SSE endpoint, streaming response, event stream, here is waiting for a message in the queue, and it times out after 5 seconds. So if there is no message, what it will do is it will return waiting for message here. So this is not only processing messages from the queue, it is also receiving message while waiting. So this is the wait count. So what is this for? Let me pass my name to it. See, status message received. So here we can send message to the server. So in MCP Model Context Protocol, this is the mechanism where we can send, that is the SSE client can send post message to the SSE server. MCP server will respond using SSE transport. I am Sri. See here, received from server, acknowledgement received, status, message, I am Sri. Clear? So this video is to show you that an SSE client, in this case, this web application, is able to continuously receive streaming messages from the server through SSE. It can also post data using normal HTTP to a REST endpoint. Okay, so here we have established two-way communication. One-way server to client is using SSE, and client to server is using normal HTTP REST. So that is it for this video. Please give your valuable comments in the comment section. Please remember to like, share, and subscribe, and see you in the next video. Bye-bye.